There are two types of geometric tolerances that are sort of extensions of the notion of position tolerance. The focus of these are the alignment of surfaces. So what we'll look at is controlling those surfaces where some type of symmetry is involved. First one deals with concentric features, and just the term concentricity implies an axis and then some concentric feature about that axis, and then just a generic symmetry that is not constrained to an axis. First of all, concentricity, we're looking at a surface of revolution, and by that we mean there's an axis of symmetry about which we generate a surface. If you're going to use concentricity, you have to have a datum reference, and therefore we need to identify the datum reference and then determine where the tolerance zone is with respect to that. We have a cylinder shape or a spherical tolerance zone, and of course it will be located at the datum. So it does have a position. For concentricity, it's slightly different than what we've seen in the past in that we're going to use surface points as shown in the figure here, and the surface points will be opposite each other within the feature. So what we're actually controlling is the median or midpoint of those two surface points. So once I know the surface points, then I can define the median. For concentricity tolerance zones, you cannot use material condition. So you will not see an M or an L in that second box. And we're not going to use a mating envelope for this feature because we're using the 2 points representing opposing surfaces. So here's an example of a concentricity tolerance zone where, as you can see from the side view here, I've got 2 cylindrical features. This is the axis of symmetry, and one of those features is going to serve as a datum. So the larger diameter will be the datum reference, which is required here. And we want to control the concentricity of this cylindrical feature, which is the smaller diameter, with respect to D. And of course you should recognize that that is the concentricity symbol. So what does a tolerance zone look like, and how do we construct it? Well, when we think about the actual position of that second feature, the one that we're trying to control, this is the feature, and if we observe the actual surface, it's going to vary because the orientation of that feature will vary, its shape, and its location. And we're trying to determine whether or not it's concentric with respect to the datum. So when constructing the tolerance zone, the first thing we want to do, because D corresponds to a feature of size, we want to use the mating envelope for the datum. So here, as you can see, we take the largest cylinder that can fit inside of the feature for datum D, and then what we're going to do is locate our tolerance zone centered on D. The width of the tolerance zone, of course, is fixed at 0.05. We can't use maximum material condition. Now, in terms of determining whether the feature lies within that tolerance zone, again, it's slightly different. What we'll do is take cross-sections that are normal to the datum, and so you can kind of think of those cross-sections as mating envelopes in a sense, but it's not the same, because what we'll do is look at the median points as we look at an individual cross-section, and all the median points have to fit within that cylindrical tolerance zone. And we'll do that for an infinite number of cross-sections. Of course, in practice, we will not be able to do that. So if all these median points lie within our cylinder over the length of the feature, then it is concentric. Symmetry can be used for both an axis or some plane of symmetry. and it must have a datum reference similar to concentricity. So it's a little more general case here. Our tolerance shape will be dependent upon the feature about which we're using the symmetry. So it could be two parallel planes if I have two planar surfaces. It could be cylindrical, or it could be spherical if I have two spherical features. So the zone is going to be located at the datum, again, centered around that datum, and will control, as we did with concentricity, the median of two opposing surface points. So here, as you can see in the figure, instead of a cylinder, now we're talking about points on a plane. And then we'll take the median point and determine whether or not that median is within the tolerance zone. As with concentricity, you can't use material condition, and of course we're not using a mating envelope to determine the location of the feature. So what does this look like? Well, going back to the slot example, if, as you recognize here, we have a symmetry tolerance symbol, then we're looking for the datum associated with that, because we're saying that this feature, which happens to be the slot, has to be symmetric about A. Well, A, of course, it's attached to the dimension line, and therefore it's a feature of size. So we will find A using the mating envelope, the smallest box that fits around that feature. Once we determine A, now we have a plane, right? Datum A is a plane. And now we will center the tolerance zone. So this is a magnified view of that. We have two planes centered around A. So we'll go down the slot and take essentially cross sections, an infinite number of cross sections, and look at all the median points. So as you can see here, I'll take this point, find the median, which is the green circle, and do that for all the points within that slot. If they all lie within the tolerance zone of width 0.1, then we say that this slot is symmetric about A. So you should understand the notion of concentricity and how it relates to an axis or a spherical feature. Also symmetry, the general case, which could be used for cylindrical or planar features or a spherical feature. And then what we're really controlling with these two tolerance zones is the median points related to points on the surface. We'll control one or more surfaces, depending upon the nature. Like in the slot, we were actually controlling two surfaces. And of course, we need the datum telling us what the other features that we're concerned about being symmetric with. The mating envelope is not used for the feature. What we do is we find the median points. Datum is always required, and material condition cannot be used. So if you see a material condition there, there's something wrong.